Good morning, everyone. The topic for today's presentation is graph traversal. Graph traversal is a technique used for searching a vertex in a graph. The graph traversal is also used to decide the order of vertices to be visited in the searching process. A graph traversal finds the edges to be used in the searching process without creating any loops. That means using graph traversal, we can visit all the vertices of the graph without getting into any looping paths. There are two methods of graph traversal that are BFS, that stands for breadth first search, and the second is DFS, which stands for depth first search. Let's start by discussing DFS graph traversal technique, which stands for depth first search. DFS traversal of a graph produces a spanning tree as the final result. Spanning tree is a graph without any loops. We use stacked data structures with minimum size of total number of vertices in the graph to implement DFS traversal of a graph. We use the following steps to implement DFS traversal. Step 1. Define a stack of size total number of vertices in the graph. Step 2. Select any vertex as the starting point of the traversal. Visit that vertex and put it onto the stack. Step 3. Visit any one vertex of the adjacent vertex which is at the top of the stack, which is not visited, and push it onto the stack. Step 4. Repeat step 3 until there are no vertex to be visited from the vertex on top of the stack. Step 5. When there is no vertex to be visited, then use backtracking and pop one vertex from the stack. Backtracking is coming back to the vertex from which we came to the current vertex. Step 6. Repeat step 3, 4, and 5 until the stack becomes empty. Step 7. When the stack becomes empty, then produce final spanning tree by removing unused edges from the graph. Now, let us understand the working of depth first search with the help of the following illustration. Depth first search is an algorithm for traversing or searching tree or graph data structure. The algorithm starts at the root node. We can select some arbitrary node as the root node in case of a graph and explores as far as possible along each branch before backtracking. Step 1. Initially stack and visited array are entered. Step 2. Visit node 0 and put its adjacent nodes that are 1, 2, 3 into the stack. Step 3. Now node 1 is at the top of the stack, so we visit node 1 and pop it from the stack and put all of its adjacent nodes which are not visited in the stack. Now node 2 is at the top of the stack, so we visit node 2 and pop it from the stack and put all of its adjacent nodes which are not visited, that is 3, 4, in the stack. Now node 4 is at the top of the stack, so we visit node 4 and pop it from the stack and put all of its adjacent nodes which are not visited onto the stack. Step 6. Now node 3 is at top of the stack. So visit node 3 and pop it from the stack until all of its adjacent nodes which are not visited in the stack. Now stack becomes empty, which means we have visited all the nodes and our DFS traversal ends. Now let's look at DFS graph traversal. DFS traversal of a graph produces a spanning tree as the final result. Spanning tree is a graph without any loops. In BFS, we use two data structures with maximum size of total number of vertices in the graph to implement the traversal of the graph. The breadth first search algorithm is used to search a graph data structure for a node that meets a certain criteria. It starts at the root of the graph and visits all the nodes at the current depth level before moving on to the nodes at the next depth level. We will use the following steps to implement BFS traversal. Step 1. Define a queue of size total number of vertices in the graph. Step 2. Select any vertex as the starting point for traversal. Visit that vertex and insert it onto the queue. Step 3. Visit all the adjacent vertices of the vertex, which is at the front of the queue, which is not visited, and insert them onto the queue. Step 4. When there is no vertex to be visited from the vertex at the front of the queue, then delete that vertex from the queue. Step 5. Repeat step 3 and 4 until queue becomes empty. Step 6. When the queue becomes empty, then produce final spanning tree by removing unused edges from the panel. Now, let us understand the working of algorithm with the help of the following example. Starting from the root, all the nodes at a particular level are visited first, and then the node of the next level are traversed till all the nodes are visited. To do this, a queue data structure is used. All the adjacent unvisited nodes of the current level are pushed into the queue, and the nodes of the current level are marked visited and dropped from the queue. Step 1. Initially, queue and visit array are empty. We will start our DFS traversal from the root node 0. Step 2. Push the node 0 onto the queue and mark it visited. Step 3. Remove node 0 from the front of the queue and visit the unvisited neighbors and push them onto the queue. Step 4. Remove node 1 from the front of the queue and visit the unvisited neighbors and push them onto the queue. Step 5. Remove node 2 from front of the queue and visit the unvisited neighbors and push them into the queue. Step 6. Remove node 3 from the front of the queue and visit the unvisited neighbors and push them into the queue. As we can see that every neighboring node of node 3 is visited, so we move to the next node that is in the front of the queue. Step 7. Remove node 4 from the front of the queue and visit the unvisited neighbors and push them into the queue. As we can see that every neighbor of node 4 are visited, so move to the next node that is in front of the queue. Now the queue becomes empty. So terminate the process of iteration. Thank you for watching. See you next time.